Hi, today we will learn about the laws of radicals. The laws of radicals can be used in simplifying radical expressions. Let's now have the first law of radical. So the first law of radical, we have the nth root of a quantity raised to the power of n is equal to a. So this is if the index is equal to the exponent. Say for example, we have the cube root of 4 raised to the third power. Keep in mind that this expression is the same as the cube root of 4 cubed. So applying the given law, this expression is simply equal to 4. Let's have another one. Let's say we have the square root of 64. First, we will express 64 in exponential form. We know that 64 is the same as 8 raised to the second power. And applying the given law of radical, this expression is equal to 8. Let's have another one. Let's say we have the cube root of 216. 216 in exponential form is 6 raised to the third power. So to simplify this, by applying the given law, this expression is equal to 6. For the second law of radical, we have the nth root of AB is equal to the nth root of A times the nth root of B. Say for example, we have the square root of 50. We know that 50 is the same as 25 times 2. So applying the given law, we're going to have square root of 25 times square root of 2. And then expressing 25 in exponential form, that is 5 raised to the second power. Applying the first law, the square root of 5 squared is equal to 5, and then bring down square root of 2. Therefore, square root of 50 is equal to 5 times the square root of 2. Let's have another example. Let's say we have the cube root of 125 x raised to the third power. Applying the given law of radical, this is the same as the cube root of 125 times the cube root of x raised to the third power. If we express 125 in exponential form, that will be 5 raised to the third power. Bring down the cube root of x cubed. And then applying the first law of radical, the cube root of 5 cubed is equal to 5. And the cube root of x cubed is x. Therefore, the cube root of 125x cubed is 5x. Let's have another example. Let's say we have the square root of 48. So what we're going to do is we will factor the radicand. We will factor 48 such that one of the factors is a perfect square. Meaning, one of the factors, we can get the square root of one of the given factors. So let us first identify the factor pairs of 48. So the factor pairs of 48 are 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So among the given factor pairs, we will choose a factor pair in which one of the given factors is a perfect square. So among the given factor pairs with a factor that is a perfect square, we have 3 times 16 and 4 times 12. So in this factor pair, the perfect square is 16. And in this factor pair, the perfect square is 4. Now, between the two, we choose the higher factor or higher perfect square. So, between 16 and 4, which is higher, 16. So, therefore, we will choose 16 times 3 or 3 times 16. So, we will choose this factor pair. So, 48 is equal to 16 times 3. Applying the given law of radical, we have square root of 16 times square root of 3. If we express 16 in exponential form, that will be 4 raised to the second power. Bring down square root of 3. And then let's apply the first law of radical. So this will be equal to 4. Bring down square root of 3. Therefore, the square root of 48 is 4 square root of 3. For the third law of radical, we have the nth root of a over b is equal to the nth root of a over the nth root of b, such that b is greater than 0. Say, for example, we have the cube root of negative 64 over x raised to the 6th power. So applying the given law, this is equal to the cube root of negative 64 over the cube root of x raised to the 6th power. If we express negative 64 in exponential form, that will be negative 4 raised to the 3rd power. Same with x to the 6th power. So x to the 6th power is the same as x squared quantity raised to the 3rd power. Now applying the first law of radical, the cube root of negative 4 raised to the 3rd power is negative 4. And the cube root of x squared quantity raised to the 3rd power is x squared. So therefore, the given expression is equal to negative 4 over x raised to the 2nd power. Let's have another example. Let's say we have the square root of 3 over 16. Applying the given law of radical, this is the same as the square root of 3 over the square root of 16. So we have square root of 3 over 16 in exponential form is 4 raised to the 2nd power. So we have square root of 3 over the square root of 4 raised to the 2nd power. So if we apply the first law of radical, that will be equal to 4. So therefore, we have square root of 3 over 4. Let's have another one. Let's say we have the 5th root of 32 x raised to the 10th power over y raised to the 10th power. So applying the given law of radical, this is the same as the 5th root of 32 x raised to the 10th power over the 5th root of y raised to the 10th power. Applying the second law of radical, the numerator is the same as the 5th root of 32 times the 5th root of x raised to the 10th power. So let's copy the denominator. If we express 32 in exponential form, that will be 2 raised to the 5th power. And then x raised to the 10th power is the same as x squared raised to the fifth power. For our denominator, we have the fifth root of y squared quantity raised to the fifth power. So if we apply the first law of radical, if the index is equal to the exponent, we can simply cancel. So for the numerator, we have the fifth root of 2 to the fifth power is 2. The fifth root of x squared raised to quantity raised to the fifth power is x squared over y squared. So the given expression in simplest form is 2x squared over y squared. For the fourth law of radical, we have the mth root of the nth root of a is equal to the mnth root of a and is also equal to the nth root of the mth root of a. Say for example, we have the sixth root of 16. So applying the given law, this is also the same as the cube root of the square root of 16. Now, if we are going to express 16 in exponential form, that is 4 raised to the second power. Applying the first law, this will now be equal to the cube root of 4. So in simplest form, the sixth root of 16 is equal to the cube root of 4. Let's have another one. Let's say we have the cube root of the square root of 8x raised to the third power. Applying the given law, this expression is also the same as the square root of the cube root of 8x raised to the third power. Now, if we are going to express 8 in exponential form, that is also the same as 2 raised to the third power. And then let's copy x cubed. Applying the first law of radical, we can simply cancel this because the index and exponent are equal. So it means that the given expression is equal to the square root of 2x. Let's have another example. Let's say we have the sixth root of 4. So applying the given law, this expression is the same as the cube root of the square root of 4. Now let us express 4 in exponential form. So we have the cube root of the square root of 2 raised to the second power. And then we can cancel the index and the exponent since they are equal by applying the first law of radical. So we now have the cube root of 2. Therefore, the sixth root of 4 is equal to the cube root of 2. Let's have another example. Let's say we have the cube root of the square root of 27. Applying the fourth law of radical, this expression is the same as the square root of the cube root of 27. Now, if we express 27 in exponential form, 27 is 3 raised to the third power. Applying the first law of radical, the cube root of 3 cubed is simply equal to 3. Therefore, the given expression is equal to the square root of 3. So those are the laws of radicals. Thank you very much for listening.